What's up, sports fans? In this video, we're going to factor quadratics using the box and diamond method. We're going to knock out all three of these, but first I need to connect this to a concept that we've already spent some time with. So let's review multiplying polynomials real quick. So say that we have this expression, 4 times x plus 3 times x plus 1, and we want to multiply or expand this expression. So we're going to multiply it. The nerdy, mathy way to describe it is expanding it. So here we go. We have 4 times x plus 3 times x plus 1. The way that we're going to expand this thing is we're going to distribute the 4. 4 times x is 4x, and 4 times 3 makes 12. So this first binomial here we're going to look at is 4x plus 12. The x plus 1, we're going to leave it like it is for now. So I'm going to bring this 4x, this 12 down. The x plus 1, we're also bringing into the mix. To use the box method, we just multiply these two terms on the outside to occupy this box. This is a 1x, this is a 4x. 1 times 4 makes 4, and x times x gives us x squared. Next box, we have 4x times 1, that's just 4x. Anything times 1 is just itself. Moving down here, we have x times 12. If you have x and you have it 12 times, that means you now have 12 x's. Last one here, it's two constant numbers, 1 times 12, that gives us 12. Now to finish this thing off, we're going to combine our like terms. We have 4x squared. There are no other x squareds in this box. We have 4 x's and we have 12 more x's. These two are like terms. They have the same variable raised to the same exponent, x to the first power. I see 12 of them in here and I see 4 of them here. 12 plus 4 gives us 16. So we have 16x and then we have a plus 12. The box and diamond method, what I'm about to show you, it does the same thing, but it goes the other direction. So we're going to start with something that looks like this, and our objective is to put the whole quadratic into the box, and then we're going to find the stuff on the outside. So when multiplying, you have the stuff on the outside, and then you're figuring out what the quadratic is by putting it into the box. The opposite is what we're about to do, doing this box and diamond method. You start with the quadratic, you put it into the box, and then we figure out what's on the outside. So this expression right here, 4x squared plus 16x plus 12, that's where we're going to begin. We're going to factor this using that same box and diamond method. Now, what I'm noticing first of all, and the first thing I'm going to look at when I approach all of these is, do we have a GCF? In this case, yeah, we do. We don't always, and as I'm looking at these right now, I'm realizing I chose 3 examples with GCFs. That was a mistake on my part. I should have picked one without a GCF, but that's okay. We can still do this. So our GCF here, GCF equals, well, I can look at the factoring chart we have in our notes. It looks like it's 4 among the coefficients, and then I'm looking at my x's. I don't see x's on all 3 of them, so the GCF is simply 4. To undistribute, we divide everything by 4. So that means we're going to have a 4 on the outside of some parentheses. Dividing this by 4, we get x squared. 16x divided by 4 gives us 4x, and 12 divided by 4 gives us 3. Now what we're going to do is we're going to put this 4 on the outside on hold. We're going to focus on this blue quadratic, and we're going to put it into a box. So here is our box. The whole quadratic is going to go inside. The x squared is going to go right here. The 3x is going to go on the bottom right quadrant. And remember how the 4x gets split up between these two quadrants. Again, calling back here, it gets split up into 2 different chunks. So we're going to be doing that same thing. We're going to split it up into 2 different chunks. The diamond part of the box and diamond process inform us how this thing gets split up. So in the top of the diamond, we front load it by multiplying a times c. Whatever our a value is, which in this case is just 1, times c, which is 3. 1 times 3 is 3. In the bottom of our diamond, we put our b value. That's 4. Now our task is to solve this little puzzle by finding 2 numbers that multiply to 3 but add up to 4. You can check your factoring chart. I'm going to work pretty quickly here. It's 1 and 3. 1 times 3 makes 3. 1 plus 3 makes 4. Now, we use this 1 and this 3 by splitting up our b value. It doesn't matter which goes into which box. This could be my 3x, this could be my 3x. Just put 1 in one box and 1 in the other box. So I'll go 1x here and 3x here. Now we put our entire quad in a box. The quadratic is in a box. X squared is here, the 4x is split up into 2 quadrants, and the 3 is here. We're gonna find the stuff on the outside. Start by focusing on the red value in the top left. We're gonna start on the top column. So we look at x squared and x and identify our GCF. The greatest common factor here is just x. Then we finish off our cornerstone by saying x times what number is x squared? And of course, in this case, it's just x. Now that's the hardest part of the whole process, I would suggest. Now we just follow the path laid out before us. X times what gives us 3x? Well, in this case, it's positive 3. And then x times 1, positive 1, gives us x. Then we can always check by making sure it multiplies to the c value. 1 times 3 gives us 3. So our factors of this quadratic are x plus 3 and x plus 1. So to finish this thing off, we have x plus 3 times x plus 1. This right here is how we'd factor the blue quadratic. Please don't forget that we factored out a GCF when this whole thing began. So that 4 is still alive and well, and it's here on the outside. So to factor this quadratic, we'd get 4 times x plus 3 times x plus 1. Real quick callback to the example we just did a moment ago. Notice that that's where we started, and then when we multiplied, we got to the finish line. What we just did a moment ago is we started with the 4x squared plus 16x plus 12, and we factored out the 4, then we put the quad in a box and found the 2 factors of the quadratic, and then we brought it all back together. So we just worked with the same quadratic and we went in both directions. We multiplied it and then we factored it. Let's do a few more examples real quick. Again, feel free to pause, rewind, do what you need to do. This one here, a value is not 1, so we're going to locate our GCF. The GCF for this particular one, it looks like it's 3x. So we're going to divide everything by 3x. When we do that, there's going to be a 3x on the outside of these parentheses. And then inside, we're going to actually do this division. 6 divided by 3 is 2x. So the third divided by x to the first is x squared. 9x squared divided by 3x, that gives us 3x. And 3x divided by 3x, that gives us 1. Now, we're going to put this 3x on hold. We're going to focus on the blue quadratic. We're doing box and diamond method. Again, we're going to put this quad into a box. The first term here, the 2x squared, we throw it on the top. The last term here, the 1, we place it in the bottom right quadrant. The 3x, we're going to split it up in some sort of way. I don't know what that way is yet, so I need to use the diamond. On top goes our AC, that is 1 times 2, which is 2. On the bottom is our B value, that's 3. We need to find 2 numbers that multiply to 2, but add up to 3. In this case, it's very similar to what we just did. It ends up being 2 and 1. 2 times 1 makes 2, 2 plus 1 makes 3. So we have a 1x and a 2x that we're putting into our box. The quad's now in a box. 2x squared is here, 3x is split up, and we have the 1. Let's find the stuff on the outside. Start above the first column. The GCF here among these 2 terms, 2x to the second and 2x to the first, is 2x. 2x times 1x gives us 2x squared. These are our cornerstones. Now we follow the path laid out for us. X times 1 gives us x. 1 times x is x. 2x times 1, coincidentally, is 2x. Then we can check by making sure the c makes sense. 1 times 1 does make c. That's good news. So this thing can be factored as 3x out front. That was our GCF. Times whatever this is, 2x plus 1. Times this side here, x plus 1. So our entire quadratic can be split up like so. Let's do one more of these and then we'll wrap this up. Again, a value is not 1, so I'm trying to find a GCF. It's always good if you can find a GCF because it makes the number smaller. Think ahead a little bit. If we did box and diamond with this as it currently is, we would be multiplying our a times our c to find the top number. That would be 21 times 14. I don't know what that is off the top of my head, but it's well over 100 and it's not on our factoring chart. So if I could make these numbers smaller, it would make my life a whole lot easier. I'm noticing that 7 goes into 21, 35, and 14. So our GCF here is 7. Let's divide everything by 7. Take special note of the negatives going on here. That's different in this one versus all the other ones. So we have a 7 out here, and then we divide everything. This turns into a 3x squared minus a 5x minus 2, like so. Now, this blue quadratic, the x value is not 1. We're going to use, or the a value is not 1. Let's do box and diamond. Put the whole quad in a box. 3x squared. We got a negative 2. Again, being careful with our negatives. We're going to split up this negative 5 in some sort of way. I don't know what that some sort of way is. We need the diamond to inform us. AC goes on top. A times C, 3 times negative 2, that's negative 6. B goes in the bottom, that's negative 5. Now this one, it's funny the way it all worked out. We're not always going to have a 1 as one of our side numbers, but this one, again, coincidentally does. This one ends up being negative 6 and 1. The reason why negative 6 and 1 work here is because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So we'll go x here and negative 6x here. Top column, GCF among these two is 3x. 3x times 1x gives us 3x squared. 1x times 1 gives us x, and 3x times negative 2, that's kind of funky how that's written. 3x times negative 2 is negative 6x, and then to check using the C, 1 times negative 2 is indeed negative 2. So this one here, when factored, we get 3x plus 1 times x minus 2, and we cannot forget our GCF, it was just 7. Now, these three examples, these are good box and diamond examples. This is about as tricky as it gets. These are the hardest versions where we have a GCF and you're using box and diamond. A lot of the examples you will look at, you ask if you have a GCF and you just won't have one. All three of these did, but sometimes you won't. That doesn't mean you're wrong. That just means the process actually goes a little quicker. You can skip this whole first step and take the quad, go right into the box. And that works. You might end up with some bigger numbers. One other thing I want to point out, what I've done here is what will be on the test. What I'm about to talk about is just to help this bring some meaning. So if you want to stop listening, you can. After we learn how to factor these, we're going to solve equations that involve bigger polynomials, mostly quadratic, but we'll look at some cubics like this and quadratics. And they're going to be equations like this stuff equals 0 or this stuff equals 10 or whatever the case may be. And as these are written as polynomials with multiple terms with x's, with different exponents, it's really tricky to solve them, to solve equations. In fact, I don't really have a way to do it without factoring. But once we factor something like this and turn it into this, if we said that this equals 0, I could solve that equation for all three values of x in, I don't know, 20 seconds or so. So it goes a whole lot quicker, and I'm going to be able to show you how to do that too after we get good at factoring. You must be able to factor to be able to solve those equations. So this skill not only is for this upcoming test, but it'll benefit us moving forward. All right, thanks for working hard. See you Monday.